OneX Developer Podcast.
You go. You do.
Hey guys, welcome back. It's another episode of the OneX Developer Podcast with myself, Colin,
I'm Brendan.
and today we're going to talk about computers.
Yeah, as usual. No, Colin had an interesting idea about concepts that only exist in computer science, right? They are unique to computer science, and they don't really have analogs in other disciplines, at least not to the same degree.
Yeah, I think like at least not. Maybe there are topics that exist more like specifically in computer science that we talk about a lot here that you probably wouldn't be exposed to in other stuff.
Yeah, because I think that, you know, there are a lot of concepts in computer science, especially now that people use computers for like everything all day, every day. Even if you're not into computer science, you're using a computer for all sorts of stuff. I think there's a lot of concepts that people do understand and that make a lot of intuitive sense. But I think we're talking here about ideas that you really wouldn't, people who aren't programming computers wouldn't necessarily come across.
Right. So this all came up for me when I was just thinking about the idea of a nullable Boolean, right? It's an interesting concept, right? The idea that a Boolean is easy to understand, right? It's either a 1 or a 0, and that's it. But every now and again, you come across a nullable Boolean that is neither 1 nor 0, but is just not, right? Like, that's a weird idea.
Yeah, it represents the absence of a value.
Yeah, it could be off or on. The switch could be off, or it could be on, or there could not be a switch there at all.
Yeah, yeah. I guess, yeah, it's on or off, or you don't know its state, right? You are in another room and you can't see the switch. I don't know.
Right. Well, I mean, if the switch doesn't exist, wouldn't that be the same as it not being on? Well, not necessarily, because it could be that the circuit is just closed all the time. It's just connected, or it could be that it's just not connected.
I mean, this is the whole problem with nulls, right? What does it mean when you have a null value in your database? Like, you have to kind of, I don't know, you got to kind of be, at the very least, be consistent with what null means, because it can mean it's always off. It could mean it doesn't matter. It could mean a lot of things.
Yeah, and sometimes it does mean something. Like, I think generally, like, created date of null, I think most people would interpret as it hasn't been created yet, right?
Yes.
In a database or something.
But why does the row exist if it hasn't been created yet?
Yeah, why is there even a created date? It should be, I mean, I don't know. Like, sometimes it might be some date super in the future if it hasn't been set yet, or yeah.
This is kind of a detour, but like, how do you feel about null values in a database in general? I try my best to avoid null values. I think they're kind of a bad thing in general. You got to use them now and again, but like,
Yeah, I think especially with a Boolean, like that specifically throws me off. I think a null date can make sense. Like,
okay.
If there's a deleted date, what should that be if the thing hasn't been deleted yet?
Right.
The only argument I could think of other than null would be the what's it, like the Unix time 1980 or whatever it is.
Yeah, the epoch.
Yeah, but maybe that was when it was deleted.
Yeah, Someone happened to delete it on January 1st, 1970.
Yeah.
Dope.
Um,
I mean, I think that, you know, proponents of like real serious no null database stuff would argue that that date, I guess, would be stored in a separate table, right? You'd have to have a separate table, and
oh, okay.
that's a pain in the ass.
Like a link table that just doesn't have a record for the ones that haven't been deleted yet.
Yeah.
Yeah.
But I think in practical terms, yeah, most people would have a deleted date that is null.
Right. So yeah, I mean, I can't think of a lot of other applications other than programming where that's something that you have to think about.
Yeah. I mean, it's just kind of a weird, it is a weird idea. Like a missing value is something that just doesn't, I don't think that just makes a lot of sense in, I don't know, anything in, maybe it's a digital thing, right? It doesn't make sense in most things that involve the physical world.
Right. Like I'm thinking in like accounting, there's like credits and debits, and with zero, I mean, it could be a credit of zero or a debit of zero, it doesn't matter. Or you could just like not, you could just ignore it completely. Yeah, I mean, but like blank fields exist, right? There are forms that you leave a field blank.
Yeah.
You just don't worry about it. You don't write anything.
But not a yes no field, right? What does it mean for, well, I guess that would be like in it from a user interface perspective, that would be you haven't selected yes or no yet.
Well, I mean, like there are physical forms like that. Like there'll be a, like, I filled out like at the doctor's office or something. It'll be like women only for this section, and then it'll have a checkbox like, are you pregnant? So yeah, I would leave it null. But that just means I'm not pregnant.
Yeah. Right.
So
could
yeah,
probably
yeah,
say no.
I see what you mean. Yeah, I could say no, or yeah, those are the same idea logically. So yeah.
But again, it's kind of interesting thinking about it on a form like that, because I think that someone who is designing that form, not thinking about the data representation of it, that seems like a very obvious idea in that case. It's just like, well, yeah, if if this field doesn't apply to you, don't fill it out. That's very easy. But then when we think about that from like how it's going to be represented in the database, that becomes kind of a strange idea of like yes, no, or it's just missing, I guess.
Or not. Yeah, because like in that example, it's either yes or it's no. If they didn't mark yes, then it's just no.
Yes, for that question, but it's not always safe to assume that not filled out means no, right? There are a lot of cases where not filled out could mean should default to yes.
Okay, like what?
Oh, I was afraid you were going to ask me that. Mark, let's see. Have you ever, I can't think of a good example, but like, I have never had this kind of surgery, right? Maybe that's just an issue with the wording, I guess, but I think there could be questions like that where the assumption is you would only mark this if this has not happened to you, right?
Yeah.
I don't have a valid government ID or something like that.
Oh, right. Yeah. Same concept, just the other way around.
Yeah. That is interesting though. I think the nullable, the idea of a null only causes issues there when you're thinking about like how to store that thing in the database.
Yeah. Otherwise, you wouldn't really worry about it. So another one, and this is something that exists in other fields, but definitely not to the same extent, is number systems. We obviously deal with number systems a lot, mostly binary, sometimes hex. Um, do people use octal for stuff?
I
Oh,
think,
for like security permissions on Linux, like 777, that's octal.
oh, yeah, I guess that's true. I feel like it used to be a much bigger thing than it is now. I I feel like a lot of stuff these days is hex where it would have been octal in the past just because like space was so much tighter back then, you know?
Yeah.
Um, I don't find myself using octal very often. I mean, I guess I don't use hex all that often, but way more often than
Yeah.
I use octal.
I mean, to be honest, you're not really directly using binary a lot either. At least I'm not. But it's something that you have to know about.
You do, and I think that, yeah, I think you think in binary more often like a Boolean field, right? Or a Boolean value.
Yeah.
You're thinking in binary, even though in real life these days it's probably stored as like 8 bits or whatever. But
Yeah.
you're thinking in terms of binary.
Yeah. Anytime you do an and or an or, that's really binary logic.
Right. Good point. Yeah, yeah. All that stuff comes out of binary.
And yeah, I don't know of, like, I don't think people are using different number systems for other types of stuff. I mean, well, in hardware people do obviously, but outside of computers, are we talking about different number systems a lot?
I think things have pretty much settled down. Like I get the impression that there used to be more discussion around number systems, right? In the age before you and I had a computer in our house, there were like different standards, and sometimes a byte was 7 bits and stuff like that. I don't really know my history here. I'm kind of talking out of my ass, but I just feel like there used to be some kind of competing standards around that, and we've kind of settled on octal and hex, and then octal is just not as used as much as it used to be.
Yeah. One thing that comes up sometimes is sometimes people will ask me like, uh, why are things always like 16 bits or 64 bits? Like, why that number? And then like I try to explain it, and I'm like, okay, well, there's like two values, right? And like then like when you get to 3, that adds like another value, and I just feel like I sound like a crazy person, you know. I feel like I'm so bad at trying to explain it, but it's something that has been explained to me and made sense.
Yeah.
I feel like I get it. I just don't know, like, you know, I don't know how to go about explaining it, but there's a reason.
Yeah. And I feel like some of the stuff I've read, if you ever looked into like the FFT algorithm, I get into that with like audio stuff sometimes, and it's like, it's important that your window size be a power of 2. Just trust me, it's better.
Yeah.
That's kind of where I stop
Yeah.
explaining it to people. It's like, it's helpful if your memory aligns with, lines up with a power of 2. Just trust me.
There's weird number things. I I learned about Fourier transforms in college in electrical engineering, but for the most part, we had a cheat sheet like this integrals Fourier transform is this, and you can use the cheat sheet to derive everything.
Oh, okay.
There's a lot of jokes like in kind of like academia that like an electrical engineer without his cheat sheet is like worthless. And there's a lot of truth in that.
Is that true? Like even electrical engineers on the job day to day, they have like a little cheat sheet?
I think so. I mean, no one's like deriving a Fourier transform themselves. It's probably less a cheat sheet nowadays and more like MATLAB or Wolfram Alpha or whatever, you know.
Yeah.
The same way, like honestly, I'm not like at this point, I'm not really writing regex myself. I'm like using an LLM or something to do it for me, because, or at least get me most of the way there, you know. I think it's kind of like that.
Gotcha. Yeah, that makes sense. I mean, it's a tedious process and someone's already figured it out, so you can just kind of, I don't know, not really a lot of reason to like memorize all that or work it out yourself.
Yeah. And so we've talked about before, like there are kind of like rumors of like these mythical like ternary computers that have 3 bit like 3 values per bit. Um, Supposedly that happened. It's kind of interesting to think like what the world would look like. It it feels complicated.
Yeah,
Feels a lot more complicated to me.
I agree.
We're going 3, 9, 27. That's weird. That feels weird.
Yeah. Is that just because that's what we know and what we kind of like have learned and grew up with? Or is it really, I don't know. There's something about it that feels to me inherently more complicated. Like, I just don't like those numbers as much.
Yeah, and I think a lot of it is because we wait. Okay, if you multiply 3 by 3 repeatedly, do you ever get even numbers?
um, I don't think so.
Let me do it real quick. Like 3 times 3 is 9. Times 3 is 27. 81. 243. 729. Doesn't it? Yeah, they're all weird numbers. Like they're all numbers that feel kind of icky. And none of
Yeah,
them are even. I feel like I want to be able to cut these in half. You know, like with a base 10 system, they're all even, right?
that's a really good point, actually. Being an even number, being able to just cut it in half is actually an important property. That's like an operation that you do often, it seems like.
Yeah, and like I know if something starts with a 5, it's half of something.
Yeah.
50 is half of 100. 5,000 is half of 10,000. You know, that feels good. Those patterns feel good.
19,683 doesn't feel good.
Yeah, no. And obviously, again, number systems existed outside of computer science. Like theoretical math people have messed with number systems, but I feel like it's something that we don't care about usually.
Yeah. I don't remember learning about number systems, for example, in school outside of computer science.
Oh yeah,
We had number when we got into like foundational stuff, there were number lines and stuff like that, but I don't remember anyone ever suggesting the idea that like, what if we based all of our counting on something other than 10?
yeah. And I remember when I did start learning number systems, I was kind of like, wait, weren't we talking about computers?
Yeah.
What's going on here? Like this is weird. um, okay, so what's another one? Uh, you had mentioned just like data types, just in general.
Yeah. I think that's one that I feel like I've tried to explain this to people about what it means to interpret just a series of bits, right? You got this series of ones and zeros, and sometimes you interpret that as an integer, sometimes you interpret that as like a character or part of a character or something like that. And I just think that's a really weird idea outside of computer science. Like when I try to explain this to people, it just feels a little fruitless. They don't really understand this idea that like the letter A wouldn't be an atomic thing inside the computer. You know what I mean? It's just at some level we have to get down to the ones, we have to get down to the hardware, and we have to get down to transistors on or off, and that involves interpreting these ones and zeros as uh, in a specific way that means something. I think part of the problem, have you ever heard this, like they'll be on TV and they'll be like, it'll just show a series of ones and zeros, and it's like this means the letter C.
Oh
And
yeah,
it's like, well, I don't know. It depends a lot on how you're interpreting it. Like, is it Unicode?
Yeah.
And so I think
It's funny.
I think just sometimes people have this idea that there's a one-to-one, like this series of bits means this letter, and it's like, well, there's a whole lot more complexity to it. There's a whole, you have to interpret that as a data type, and it might, some letters are more than 8 bits and all that kind of stuff.
Yeah. Well, and I mean, it is interesting. Like, I remember in like learning C that letters will evaluate to greater than or equal to a number.
Mhm.
Like, you could say is A greater than 0, and it is, which is like, when you see that the first time, you're like, okay, but because it's interpreting that as 32 or whatever. I don't know.
Yeah.
So yeah, it's interesting, and yeah, I don't know if we think about that. Like, are you ever prompted when you're doing addition? Do you ever have to stop and think, wait, are both of these numbers that I'm adding? In day-to-day life,
outside of programming?
Yeah, outside of programming, like not really.
No, it seems counterintuitive to have that operation even work in C.
Yeah. But yeah, we have to worry about that a lot when we're programming, right? Is this null? Is this none?
Yeah.
Is this the letter A, or is this the variable A that means 1, 2, 3 or whatever?
And it feels like that's kind of what you had in mind with this concept, because like it's really reliant on the fact that computer science comes down to the hardware in the end, right? This whole idea of data types wouldn't, maybe like you're saying, like you don't really think about this in your day-to-day life because you don't really have to, but when it comes to computers, you do have to, because of the fact that in the end it comes down to the ones and zeros in the hardware.
I think you're kind of getting it. Like, I think that's really it. Like, it's in computer science, you're doing math, but with like physical limitations.
Yeah.
Right. Like, I mean, another one that I had written down was caching and memoization. Right. That's something that I don't know if there's problems like that in other fields, but it's a problem because it becomes complicated because theoretically it all makes sense, right? Like, in theory, if it's cached or it's not, you know what I mean? But like in practice, there's a limit to how much cache there is. There's a limit to when cache is going to be cleared at certain times. You may or may not know when that is. So that's what makes it all complicated.
Right. In mathematics, there's probably no such thing as caching. I don't know, maybe I'm wrong about that, but there's probably no idea of that because you're just working with like theoretical abstractions, right? There aren't any physical limitations to calculating an infinite series or whatever. You can do things like that you can't do on a computer just because your resources are finite.
Right. So another one would be like, in computer science, we talk about big O notation, which, neither one of us really is computer scientists, right? We're like day-to-day programmers, but the idea of algorithmic complexity, or at least the idea of algorithms, comes up a lot in math, like limits and series and systems and all this. But never am I really worried about how complex it is beyond just how much it hurts my head to think about when it comes to math, right? Like, I can write it, I can have a super intensive algorithm, but once I put it in a computer, that's something I need to think about. How's it going to execute?
Yeah, that is really interesting. I feel like this comes up often on the podcast, this idea of when software and hardware kind of meet, and that's exactly right. It's like, this isn't a problem that exists until you have hardware involved, and you have to kind of like fit the concept into the physical limitations. I mean, that's really why the ternary computer would be interesting. It would be interesting to see a world where that took off, and there were even a world where there were competing standards, and just, I don't know, I'd just be curious to see real world applications of this technology that I think nobody's messed with for decades, right?
Yeah, this feels like something, and I'm sure somebody's done something like this, but this feels like something you see someone post on Hacker News, like I built a 81-bit ternary Nintendo 64, Nintendo 81, and like you look at it and you're like, wow, that's really cool, but you wasted a lot of time, and I'm glad I'm not the one who did that. Yeah, I feel like there's something out there like that.
Oh,
Like
there's got to
someone
be.
built a at least like a theoretical ternary computer in Minecraft or something.
I was just going to say, I bet it's easier to build a ternary computer in Minecraft than it is to build one in real life and real hardware.
Yeah, I mean, like if I wanted to buy a 3-bit transistor, is that something I can do?
I don't think so. I think you have to build something. Yeah, I think you'd have to custom build something that is capable of representing 3 different states.
Okay, I'm gonna make a Minecraft mod that allows Redstone to have three states.
I mean, on a more serious tip, I bet you could do it with something like a virtual machine, right? A ternary that runs on top of binary. I think at that point you're losing a lot of the, you can't do an apples to apples comparison of like binary to ternary machines, but I bet you could do something like that. You could do some kind of thing that had 3 states and like build a whole computer out of it, basically. Or
yeah. I mean, you could abstract it out somehow.
that'd be kind of fascinating, actually.
Okay, I found a YouTube video of a Redstone tri-state toggle memory. This is from 13 years ago. This video isn't available anymore. They don't want us to know.
I know. Something's being covered up here, man. This is now a conspiracy podcast.
Yeah. Okay. Where else were we going with that?
The other thing I was just thinking about was like the idea of abstraction in general. And I think that, I don't know, that's a little bit of a weird one, just because I think that you can think about abstraction outside of computer science. And I think that it's even helpful to. I think it's really helped my thinking about the world in general to think about abstractions and like just the idea of like factoring out the kind of like the lowest common denominator, and seeing, I just think it's helpful to recognize patterns that way of like, this, I've seen this part of this thing, and this is similar to like this part of this other thing, and these are kind of the same concept that exist in 2 different domains, that kind of thing. But I think there's like a version of that that's kind of specific to computer science, which is maybe what's involved in like refactoring a function. I wouldn't know how to explain that to a non-programmer of like, well, I have this function over here that does this thing, and I have this function over here. I want to create a function that is kind of like the most general version of each of those, and is kind of like a base. It forms the basis for these, and these 2 functions now become versions of that function, just with different parameters or something. And that's like straight out of math. Maybe that's not so specific to computer science, but just I think I'd have trouble explaining that to somebody who wasn't into programming.
I feel like I get what you mean. Like someone explained to me once, like that programming can be almost like, so like if they're building a house in your neighborhood, you drive by and like one day they're like digging a hole, and then like, a couple days later they're like filling it in with concrete or whatever, and then eventually there's like studs put up, and then eventually they've got like windows in and drywall, and then last they're like painting and doing the lawn, and it's that clear progress. Whereas like software, and this is why estimating is like almost impossible. It's like you drive by and today they put the windows in, and then tomorrow they dug the hole again, and then the third day it's done. And it, it just doesn't seem to have that linear. If you're doing things well, it should, but a lot of the time it doesn't follow that.
Yeah, no, that's exactly right. I always think that as I get better at programming, I'll get better at doing things more in a more linear fashion like that. And I don't know, maybe I have, but no, it's often more like what the second thing you described of like kind of do this over here and I kind of do this over here, and then I kind of connect the pieces and I go back and rewrite half of it.
And you just never know. I've been struggling a lot lately with, like, this is kind of off topic, but I've been struggling a lot with estimating lately, more than usual. Like, because I always struggle with it. I think everyone does. But it's just like, how do I know how much work something's going to be if I don't know what the solution is yet?
Yeah.
You know, like how long do you think it'll take you to find a solution for something? Well, I can do some investigative work and let you know, but then at that point, I already kind of did it. So, it's so hard.
Yeah. No, that's it's 100% right. It's like the actual investigation, determining what needs to be done to fix the thing is like at least 50% of fixing the thing. Often it's just one or two lines of code. And I think,
like, sorry, go ahead.
I think that's especially the case with bugs, which, I think that new features are maybe a little bit easier to like, well, if we're just going to add a new thing onto an existing thing, that's a little bit easier to estimate than trying to figure out what's going wrong when especially when a user comes to you and they're like, I close this window and it crashes. It's like, okay, that could be a million things.
I agree, because the bug is there because it's something you already overlooked.
Yeah.
So like you have to find where, like, the thing that you already didn't think of, you have to go think of now. Like, that's hard. My favorites bugs too are those ones that are like, sometimes this breaks. Yeah, those are the worst, man.
Absolute worst.
Yeah.
And even when you can reproduce it, but it's just an occasional bug, it's just so frustrating. Like, I just sit around and click things until it breaks sometimes.
Yeah. And hopefully there's a good log.
Yeah.
What I was gonna say is, like, I definitely agree. Bugs generally are harder to estimate, but there's also like things where, okay, we're using this new feature with this tool that we haven't used before, and then you're like, okay, yeah, it'll be, take a week, and then by the end, like almost the end of the week, you're like, oh, this tool has this limitation that's going to make the whole thing not work.
Yeah.
Like that can happen. Like, oh, this doesn't integrate with this other thing we use, and yeah, or this is they're releasing a new version next month, and the version we're on is going to be deprecated, and the new version is completely different, and so now it's a whole different thing.
Yeah. One of my least favorite things about programming in general is like deciding on a framework for a non-greenfield project.
Yes.
Like, I really hate that process of evaluating different frameworks and looking at them, because it's always exactly what you're saying. It's like you pick, you do some reviewing and you look at demos and you do stuff, but like until you've really written some code with a framework, you really don't know, man.
You don't know. And it get like, okay, we're getting way off topic, but like it's just so much of it too is not even like code stuff, right? Like, so much of it is, how is this maintained? Or is the community active around it? Is it documented well? Like all these things that are like ethereal, and you just don't know until you know.
Yeah. Yep. We're having to do a thing at work right now where we're like pulling a software project because it's just like, it doesn't seem like it's well maintained, and it's just at some point you got to go with something else if things aren't getting, if the software is not improving and all that.
Yeah, we're going through something similar actually. Okay, so the only other concept I had written down that is something we talk about in computer science, maybe not in a lot of other things, is just variable names, or really maybe even just naming things. I mean, we name things in other fields, but I feel like it has less implications.
What's that famous quote? Like, the two hardest problems in computer science are cache invalidation and variable naming, or something like that.
Yeah. We mentioned both today.
Yeah.
Uh, yeah.
Yeah. That's a yeah. Variable naming is a funny one. That, I think part of the issue is just that the variable names, they really only matter to the programmer, right? They don't matter to your program. Your program just needs a way. You just need a way as the programmer to reference a thing, and then later on your programs just like discards that information.
Yeah. I mean, the only thing, like, naming things matters outside of computer science. There's a lot of things we run into that are, oh, this is a misnomer. This is, this name doesn't describe this well. But I don't know. I feel like it's just so apparent in code when something is named poorly.
And I think it can be so like misleading. It can send you down the wrong. It can really hinder your like comprehension of the program, I guess is the way to say it. If something is named, especially if you think it's, the name should be referring to one thing and it actually refers to a different thing.
Yeah.
Variable names. Do you find that variable names, I don't know, how good do you think you are at naming your variables? Let me ask it this way. If somebody else is reading your code, not so much that you come back to it later and know what you were thinking, but if somebody else were to read your code, how do you think they would rate your variable naming?
I think my variable naming is pretty good.
Hmm.
Like, I don't know. I don't always write the most readable code. Definitely not. But I think variable names specifically, I think I do pretty good.
Nice. That's good. Do you spend time? Do you ever go back and like, oh, that was a bad name, I'm gonna
Oh,
fix
for sure.
this? Oh, good.
I've done that. Yeah. Yeah, I definitely do that.
I think that's the one that really hoses me, and it just comes out of like pure laziness. Is I'll pick a name that seemed appropriate at the time, and then kind of like, I don't know, the scope changes, and it's like, now this variable isn't really descriptive, and I'm too lazy to go back and fix all the instances of this variable name.
I mean, I probably have. I'm sure I've got some bad ones, but I don't know. I feel like I'm biased here, but I feel like I'm good at it. The thing that happens to me a lot is I'll make a variable name that's like really long because I want it to really describe things accurately.
Mhm.
And then I'm like, my lines are getting super long and I'm like, this is too long of a name. But I don't want to abbreviate stuff, that happens to me.
Yes, no, that's exactly what I was thinking. I think I'm too wordy with my variable names. X has a appropriate attribute or whatever. It's like, that's the tricky part about naming. They can't be too short. You don't want to just call it D, but also you can't be 40 characters long either.
Yeah. I like look through some stuff I've written. Like, are these good names? These are good names. Got like, I didn't write that part. I didn't write that part either. Message channel. It's kind of easy, simple function, I guess. Scores one. I think, yeah. But yeah, naming things is hard, and I just can't think of really a good example of somewhere where that's a thing. Something that is kind of tangentially related that I find interesting is that so in math, when you work with imaginary numbers, they put the letter I next to the number, right? to signify that it's imaginary.
Mhm.
Which is another, that's another topic that's like outside of math. You're like, what is an what? I like, does anyone really know what that is? But in electrical engineering, we use the letter J because I represents current in electricity world. I remember telling a math major that, and they were like, "That is so wrong. That is so disgusting. That's so weird. It should always be I." And I mean, that is weird. I guess that's somewhat related. So I guess math has it a little bit with variable names, but
I feel like the issue in math is that with a lot of math stuff, you're not really supposed to be reading it. Like, you really have to read it inside of a specific context, right? Like, if we're talking and I just say I hat and J hat, you like those mean very specific things in the context of linear algebra, right? Like, they're only defined given some other stuff. And so I almost think that math, like a lot of bad variable names, almost come from these mathematical ideas where people assume that you're already familiar with the mathematical concepts around them. And so it'll be just like, dx equals this, and it's like you already have to know that we're talking about the realm of calculus and that we're talking about derivatives and stuff like that.
I mean, I would venture to say that a lot of mathematics notation is straight up just bad. Like, it's just not good. It's overly complicated. I would say that's probably true for like a lot of music too. Just talking off the cuff, like music notation is weird and hard to wrap your head around, and it seems like it could be easier. I don't know.
Oh, wait, that's fascinating. What would you do to improve music notation?
Well, I mean, tablatures are like an entire thing, which isn't really like, because a tab is different for every instrument, right?
Yeah.
But that to me, I think, proves the point, right? That there's an entire like new notation that was invented by people to like to fix what they find hard, which is music notation itself.
Yeah,
I think treble clefs are too hard to draw.
That's fair. Yep.
They shouldn't. That's. I think one thing I'll say is I think sometimes it's not that legible. Like so if you ever like have like thick print on a paper or like a photocopy of a photocopy. This is something we would do in band. I guess is why I know. Like if you have a photocopy of a photocopy, it's hard to tell. Like, is that on the line or is that on the space?
Oh.
Is that two flags on that note or three? I don't think it's super legible sometimes.
Would bigger print fix that? Like if it was, but you can't go too big because you got to have like a reasonable number of notes on the page. You don't want to be flipping
the page all the time. Yeah. I don't know. It feels like there's got to be a better way.
I remember. Sorry, go ahead.
Music, maybe I'll walk back, but I 100% math. Like a lot of the notation in math was just made by some guy in the 1500s in France or whatever, and that was just kind of what everyone started using.
Yeah.
So yeah, that without a doubt, there's some stuff. I mean, like you'll look at some things in mathematics, they're like not really that complicated of concepts, but like they are written in a really scary way. That's something that happens a lot.
What's an example of that? Sigma? You think sigma's pretty scary?
Oh yeah, for sure. Sigma. Like, what's that E thing? Oh, it's just I'm just adding these together.
Yeah, it's just a for loop.
Yeah, really. And I mean, I think you mentioned dx. I think derivatives are not simple, but they don't have to look like that. Integrals too.
I still don't understand with respect to. I don't understand what that means. You know what I mean? Like derivative.
Yeah. Why?
With respect to x.
Yeah.
I feel like I've heard people explain integrals and derivatives in a way that really like related it to less calculus specific concepts, and I've just never been able to wrap my head around it.
So how much calculus have you taken?
I mean, really, no formal calculus since high school. But I don't want to brag. I did the Khan Academy calculus course
Okay, yeah.
when I was like
Uh,
10 years ago.
I remember a professor saying once that you don't understand algebra really until calculus, or it was you don't really understand college algebra until calculus 1, and you don't really understand calculus 1 until calculus 2, and that's like real as hell. Like in calculus 1, you learn about derivatives and integrals, and you kind of think maybe you get it, but then like later, I think in calculus 3, you do like multiple derivatives and multiple integration, and that then you start to like get it.
Okay.
More. I still don't get it enough to like explain it to you, but like I feel like at that time there were things that started to click more.
What's so I understand like the basics of calculus, you're calculating area under a curve, but like what's a multiple derivative or multiple integral? Like what's a real world thing where you would use that?
So okay, multiple derivative I might have made up actually, but multiple integration is it's the same thing just in 3 dimensions. So like a regular integral is area under a curve. If you do 2 integral, like an integral this way and an integral that way, it gives you the volume of a shape, whatever.
Gotcha.
So it's actually really simple if you already know how to do integrals. And you do, and it's the with respect to thing, right? So you would take the integral with respect to y, and then with respect to z, I guess x, y, you know, whatever. You do it 2 ways, and then that gives you the volume of this thing. And you could potentially do that more and more and more, but you know, beyond 3 dimensions, it's like that's for like smart people to do, really smart people to do.
That's interesting. I would like to know more about calculus. Hey, I thought of another thing though that is kind of unique to computer science. This idea of like runtime and compile time. I don't know that there's I can't really think of an equivalent in another discipline that's like you kind of write your stuff and then there's like that it's a multi-stage process where you kind of do a thing and then it transforms into another thing that's more accommodating to the hardware, and there can still be bugs, like you still could have made a mistake, but some errors can be caught during this one phase and some errors can only be caught in this other phase.
Man, only like I can think of like vague comparisons, like stand-up comedy like improv acting versus acting.
Yeah.
If that's still that's I feel like that's different. Like that's a good way to conceptualize it for someone who doesn't know what you're talking about, but I don't think that's the same thing.
Because the interesting thing about the computer science example is that they're the same. The program you wrote is the same thing. It's just transformed. And
one
way is more friendly to the programmer, one way is more friendly to the computer, but at the, they're really at their core, they're the same thing.
Yeah, that's interesting. Because like you think about like a live album versus a studio album, and they're different. They sound different. The energy's different.
Yeah.
I guess it's the same music, but it's totally different, yeah, that's a good one.
Just compilation in general really is like that's really something that only exists because of the computer and the hardware. Yeah.
I mean, I'm trying to think, like, is there something else where you like load something up to be done? Like I mean, yeah, I don't know.
There's got to be a lot of processes like within a factory or like an industrial setting where you're transforming one thing into another thing that makes it easier. And and probably there are probably analogs in math that are like we kind of like apply a transformation from this thing so that we can then this formula only works on it when it's in this format and that kind of thing. So I think there are probably some analogs in computer science or in mathematics.
Yeah, I mean, there's a reason why a lot of computer science schools were just part of the math department early on.
Yep.
That's always weird though, because then it's like like day-to-day programming, I'm not really doing math. Like it's weird.
I think that turns a lot of people off. I don't think people really grasp how little math I do on a day-to-day basis. I think there are a lot of people out there who are like, I didn't really like math in school, so I can't be a programmer. And it's really interesting, just like you were just saying, as much as computer science came out of math and depends on math, like the day-to-day work of being a programmer for most programmers just doesn't involve that much math.
Yeah, the only time I've really had to do a lot of math is when I was doing like game, like 3D game development,
Mhm.
and that actually makes it really hard and kind of suck, honestly.
I've been messing around with a lot of graphics stuff lately, and yeah, I've been having to relearn some trig and some linear algebra stuff, and it's just like, man, I wish I was better at this, but I've forgotten all of it.
Yeah, same. All right, do you want to jump into whose side are you on?
Let's do it.
Well, hey, this is perfect segue. Compiled languages versus interpreted languages.
I think both
And
have.
none of this. Both have their application stuff. We're picking a side.
All right.
There's one that's better.
If it's going to be like that, it's compiled. I want to catch errors at compile time. I want my program to be as correct as possible before the user of my application runs it.
I think there's a good case to be made for compiled. Yeah, that's nice to have that peace of mind and to have it all bundled up and ready to go. I really like having a REPL though, like being able to just interact with my code to real quick see if something works.
Yeah, that's true.
That's nice. Also, I've been writing some Rust code, and the compilation, it takes so. I know this is like kind of a meme at this point in the Rust community, but it really takes so long. Like I'm waiting for it to compile a long time.
What are we talking about? Multiple seconds just for like a single change?
A couple seconds, yeah, for a single change.
That's a lot.
Yeah. When you don't know Rust, and so you're like making changes constantly, trying to fix little things, yeah, it sucks.
I'm surprised that's still as bad as that. That actually probably answers one of my questions. I was going to ask you, I've heard about like C++ REPLs or something where it basically like you can write something and it creates a C++ program for you and like recompiles it immediately.
Oh, yeah.
But maybe, and I was going to ask you if that's still a thing, if people use any of those, but it's not, I mean, if it's anything like what you're talking about for Rust compilation, that just sounds like it's not even viable if it's taken multiple seconds per command.
I mean, like I said, I'm new to Rust, so I don't know. Maybe there is. Maybe I'm doing something wrong. But that's been my experience so far.
I think the real answer though, a lot of it depends on where your bottleneck is, right? Like a lot of the stuff that I write on a day-to-day basis is web-based stuff, and the bottlenecks for when bugs happen and when performance issues happen is like it's almost always the database or the network. It's never Python. Like Python is never the performance issue in the stuff that I'm writing. I I have to try pretty hard to like write Python code that takes too long. You know what I mean? That said, like I've messed around with some audio stuff and some graphic stuff where performance is really a big issue, and that's you have to give up that flexibility that you have with Python in order to get the performance. So like if those things, if performance, if really good performance isn't an important issue, then yeah, just give me like the non-compiled language, the scripting language.
Yeah, I think so. Want to do another one?
Sure.
Mono repos.
Oh,
Yes or no? Mono reapers. Start calling them reapers.
it sounds like one of those crazy hot peppers. Got yourself a
Yeah,
mono
the
reaper.
ghost reaper. Mono reaper.
I don't really have a lot of experience with this. I tend to think that mono repo. Okay, when people say mono repo, does that mean that it includes multiple languages and stuff like that, multiple frameworks, multiple languages, and all that?
So I'm not sure. When I hear it, I usually think of like, okay, my back end and my front end, I've got in one repo, but it's all like part of the same product, sort of, right? That's what I think of. So potentially, yeah, you've got, your Python backend and your JavaScript stuff in one repo.
That seems a little crazy to me, to be honest. To just be mixing frameworks and languages willy-nilly. I think even just from a conceptual place of thinking about the repo and how the code is organized, it seems like it makes sense to me to have some kind of separation, like back end, and you got this language on the back end, you got front end, and this language on the front end, and all of its all of its frameworks and all of its tests and all that stuff. Like I just think it makes a lot more sense to separate those conceptually and then separate them on disk.
I'm starting to realize maybe I don't even really know what this means, but I'm trying to read real quick. I think I like mono repos.
Okay.
Mostly because of releases. Like, so a project I work on now has poly repos, right? We've got like 3 different repos for this one web-based application. And whenever we do a release, we define a new release in GitHub for each one, regardless of if there's changes in that specific repo or not.
Yeah.
And if we don't do that, then we end up with like different version numbers for each one, which is weird because it's really one product. So I like the idea of having it be one GitHub repo at least, and then every time anything changes, there's a new version out. What I haven't really thought about, because I don't really do this much, is like in a mono repo, does like CI/CD pipelines get complicated? I feel like they might.
Yeah, I would think so. I would think that you'd have to, like, that's kind of what I mean about multiple languages. It seems like every kind of like testing framework and every kind of, CI stuff that you do seems like it would have to accommodate multiple languages. That seems weird to me. I guess if they're all just shell commands that you're running, you can, call different tests to run different stuff, but that still seems a little weird to me.
I mean, it could actually be easier because then like you're in full control of the order in which things are getting built, like in your Docker file or whatever. And like in Docker, at least, it's really easy to say like, okay, this directory is where this is, and this directory is where this is. I don't know. I'm starting to think maybe I don't even really know much about mono repos.
Let's talk for a second though about about what you were saying about releases, because I think that's that seems like it makes a lot of sense, but wouldn't it make more sense to like have the project organized such that I don't know, the back end was almost like a library of sorts, and you would be like, this release of the program uses this version of the back end, right? And if you didn't make any changes to the back end on that release, then it could just use that same version. Like, why is that a pain?
That I feel like there's a reason why we don't do that. We've gone back and forth on it as a team, and I was kind of more in favor of doing that. I don't remember why, but there was a reason why someone didn't want to do that. That's probably what we should do. Is each part of each part should have like just its own version.
I mean, it's certainly easier to say like application release 1.8.3 rather than, and then you got to be like, well, which version of the backend does 1.8.3 use? But I don't know.
Oh, right. Yeah. That could happen.
That's still, it just doesn't seem like that should be that big a deal to me. It seems like you should be able to just be like, it seems weird to increment the version even if you didn't touch anything. You know what I mean?
Oh, I think what it was is in the event that like we have to do a rollback, then we have to go to the last release and we have to look at which thing was, as opposed to just saying like, okay, move everything back to 4.9 or whatever. We have to see what changed to what. And that's not that hard though. Really.
So do you have something sitting outside of the 3 repos that like compiles them into a release or something?
We do, yeah.
Okay.
There's a separate repo for DevOps, and that's kind of managed by different people. So maybe they like it that way.
Yeah.
That might be it. I think they might just want one number for all 3 of our things. I
mean, Google famously, at least at some point, was using a mono repo, right, for all their stuff. And
yeah,
I don't know if that's still the case, but they were having, like, my understanding was that when you worked at Google, you would check out like a chunk of the repo. You wouldn't just like git clone the whole thing. You would somehow get the parts that you were interested in. Maybe they were sub modules or something. I don't know.
Yeah. So it probably depends. Just like really all of our whose side are you on things.
Yeah.
But I think I'm cool with it. I know there's been like in recently, I know there's people that like really hate the mono repo thing. But I don't really know why. I feel like if multiple projects are related enough, I think it makes sense for them to be, one big repo.
And I think it really depends on the size of things, right? Once, mono repo's fine if you're just like doing a little web page, like it's no big deal to mix in some TypeScript and some Python and like put it all in one repo under the heading of one website. But at some point, that just seems to me like it gets too much to manage.
Yeah. All right.
Boo, mono repo.
Mono Reaper. Give it up for Mono Reaper.
That's our doom metal band.
Yeah, dude. Well, I think that's it for today's episode then.
That was good. I like that.
Stop recording. Bye.
See ya.
1X Developer Podcast.
Hey everybody, this is Colin. First and foremost, I want to thank you all for listening to this episode of the 1X Developer Podcast and let you know that if you have any questions, comments, or if you just want to tell us about your day, you can reach us at X, formerly known as Twitter, at 1X Developer Podcast. We're also on YouTube at 1X Developer Podcast. You can email us if you're weird at 1xdeveloperpodcast at protonmail.com. And lastly, don't forget to follow, subscribe, all that stuff, so you don't miss any further episodes of the 1X Developer Podcast. Thanks so much. See you next time.